Hey, Stats Kids. Today we're looking at lesson 6.3, confidence intervals for a population parameter on Stats with Mr. Forbes. Notes out, and away we go. All right, so far we've looked at two confidence intervals. We looked at a confidence interval for the mean, where we know this population standard deviation. That's our Z distribution. We looked at a confidence interval for when we don't know the population standard deviation. That's our T distribution, the one we have to look up in the book. This is our third confidence interval. For this, we're going to look at population proportions. For that, we're going to use a point estimate, the point estimate for population P. Now we're going to have some new symbols for this one. The probability of success in a single trial of a binomial experiment. So we talked about that back in chapter 4 when we looked at discrete probability distributions, is P. So P is our population proportion. So the point estimate for P is the population proportion of successes in a sample. Now, and then we're going to denote that by P hat. So this is a new symbol. The P has a little character above it. Looks like an upwards arrow kind of thing. We're going to call that P hat. P hat is X over N, where X is the number of successes, N is the number in the sample. So in chapter 4, when we looked at discrete probability distributions, we looked at P being the percentage of successes, Q is the percentage of failures, and this is going to be the same thing, except P hat is going to apply to the sample, whereas P is going to be the population. We're going to do that same thing with Q. So there's P hat. So the population is P, the sample statistic is P hat. We'll do the same thing for Q hat. So Q hat would be the sample failure percentage, and that's got to be 1 minus P. And we're going to call that Q hat. We're going to start by finding some examples of P hat. So in a survey of 1,000 US teens, 372 said that they own smartphones. Find a point estimate for the population proportion of US teens who own smartphones. Therefore, P hat is how many we want, the 372 over 1,000, which is 0.372. If we wanted to, we could find Q hat. Q hat would be 1 minus P hat, which is 1 minus 0.372, which is 0.628. Example 1B, point estimate, survey of 1,000 US adults, 662 said it is acceptable to check personal email while at work. Therefore, P hat would be 662 over 1,000, which is 0.662. Q hat then would be 1 minus that, which is 0.338. Try it yourself one. In a survey of 2,462 US teachers, 123 said that all or almost all of the information they find using search engines online is accurate or trustworthy. P hat then would be 123 out of 2462, which is 0.0499. We're going to typically go to 3 decimal places, so we're going to call that 0.050. Q hat then would be 0.950. So there's an introduction to our P hat and our Q hat as our point estimate. The next thing we're going to look at is our confidence interval. So a confidence interval for the population proportion P. We're still going to do the same thing. So this looks exactly the same as it has looked in previous problems, except now we're using our P hat population parameter, or our sample parameter, in place of P. Now to calculate our E, we have a new formula. And so E is now going to be the ZC score times the square root of PQ over N. And so here's going to be the steps that we're going to follow. For our confidence interval for a population proportion, we're going to identify the sample statistics N and X. That should be given to us in the problem. We're going to find our point estimate P hat by dividing X over N. Because we're doing a population proportion, we're going to have to use NP greater than or equal to 5. Actually, NP hat greater than or equal to 5, and NQ hat greater than or equal to 5. Same thing we did in chapter 5. Then we want to find our critical value. We can either use table 4, or we're going to inverse norm. Again, 1 minus C over 2 would also work for that. Then we're going to use this formula to find the error. Then we're adding, subtracting like we've done in the last two videos. And so let's work through some. So let's construct a confidence interval for P. Use the data in example 1 to construct a confidence interval for the population proportion of US teens who own smartphones. So we know N is 1,000. We know P hat is 0.372. We know Q hat is 0.628. And we want a confidence interval of 0.95. That came from right there. We need a Z-score for 95%. So let's review that. You can either look at that table under normal distribution, or again, to do that, we're going to do second distribution, inverse norm, and we're going to do 1 minus 0.95 divided by 2, which is 0.025. And we want the area to the left, and we'll paste that, and that's our negative 1.96. So our plus minus 1.96 is our ZC score. Therefore, we're going to calculate our error. Our error is using the formula, our ZC score square root, P hat Q hat over N. And we're just going to plug in numbers. So this is plus minus 1.96 square root. P hat is 0.372 times 0.628 all over N. N is 1,000. We're going to punch that into our calculator. We're going to get 0.030. So what do we have? Well, we're going to subtract and add that, not to the mean, but now to our population parameter. So we're going to take our 0.628. Hang on, I'm missing something from example 1. Yep, we're going to take our point. I did something wrong. Oh, we're taking our 0.372. Sorry, I used the wrong number. So we're going to take our 0.372 minus our 0.30. That's got to be less than our population parameter is less than 0.372 plus 0.030. And that gives us a 0.342 is less than P is less than 0.402. So we are 95% confident that our interval has to be somewhere between 0.342 and 0.402. Now remember, this is a percentage as a proportion, so it's going to always be a decimal. It's got to be between 0 and 1 when we do this. Let's look at example 2B. Use a survey of 1,000 adults, 662, said it was acceptable to check personal email while at work. Construct a 95% confidence interval for the population proportion while at work. So again, our N is 1,000. We did this as the second problem. P hat was 0.662. Q hat was 0.338. Our confidence interval is 0.95. That gives us a ZC score, same as what we used up above, plus minus 1.96. Therefore, we can find our error. Our error then is our ZC score square root P hat Q hat over N. That's plus minus 1.96 square root 0.662 times 0.338 all over N, which is 1,000. And we'll type that into our calculator, and we get, again, funny enough, 0.030. So we're going to take that again to our point estimate. So our 0.662 minus 0.30 is less than P is less than 0.662 plus our 0.030. And that is 0.632 less than P less than 0.692. So we are 95% confident that if we would take another sample of 1,000 US adults, that their point estimate, their population P hat, will be between bigger than 0.632, less than 0.692. 5% chance it could be outside, 95% chance it should be in that interval. And we're going to work through some more examples. And then we're going to talk about how we could do this on the calculator. Let's work through a couple more examples. Use the data and try yourself one to construct a 90% confidence interval for the population proportion of US teachers who say that all or almost all of the information they find using search engines online is accurate or trustworthy. N was 2462, X was 123, our P hat was 0.050, our Q hat was 0.950. Our confidence interval now is 0.90. We need to find our ZC score. And that's going to be inverse norm. Here we have 1 minus 0.9 over 2. That's going to be 0.05. So second distribution, inverse norm. And now we want 0.05. Left, and paste. And that's our plus minus 1.645. Now we're going to find our error. Our error is our ZC score square root P hat Q hat over N. That's our plus minus 1.645 times square root. Our P hat is 0.050 times our Q hat 0.950 over 2462. We're going to plug that into our calculator, which is 0.007. We're going to add and subtract that then to our 0.50. So 0.050 minus 0.007 is 0.043, less than P, less than, add 0.007 would be 0.057. Okay. We can also look at this using our calculator, and I'm actually going to skip the rest of these for time's sake. But when we go to our calculator, we're going to go to stat test, and let me show you that. So stat test, and now we want 1 proportion z-test. So the 1 proportion z-test, option 5. And here's how this is going to work. We want our population p hat. So p naught is their p hat. So that's 0.050. Our x was 123. Our n is 2462. And we're just typing in those numbers from the problem. And then now what do we want? Not equal to, greater than, or less than. I am using the wrong option. I should have checked that one to start. Stat test, I want z interval. So we want option A, 1 proportion z interval. I messed that one up. So we want option A, 1 proportion z interval. Sorry about that. So we want 1 proportion z interval. Our x is 123, our n is 2462, our confidence level is a 0.90. We're going to calculate that, and there should be our answer. So there's our 0.043. Now notice if you round, you're going to get the same answer. And 0.057, again, rounding, we get the same answer. Let's go back and look at previous problems using our calculator as well. So let's go back to example 2. Again, to get that, we're going to go to stats, test, and we're going to go down to option A, 1 proportion z interval. Our x, we have to go back and get it, but our x was our 372. Our n was 1,000. Our confidence level is 0.95. And if we calculate, we're going to get our interval. There's our 0.342 and 0.402. Again, if we round, we are correct. So there's that using your calculator as well. I'm going to skip these two for time purposes. Just like in the last section, we looked at a minimum sample size. We can do that same thing for a population parameter. For a population parameter, the formula for a given sample size is this formula. N is equal to P hat Q hat times ZC over E quantity squared. Again, this formula assumes you have an estimate for P hat Q hat. If we don't have an estimate for P hat Q hat, we're going to use 1/2. So if we don't, then we're going to let P hat equal 1/2. We're going to let Q hat equal 1/2 if we don't have an estimate. So here we go. So example 4, you are running a political campaign in which to estimate with a 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum size needed. So we need to identify our pieces. So first we need our p hat and our q hat. Well, notice they don't give us a p hat and a q hat. Therefore, we're going to use this rule. We're just going to use a p hat of 1/2 and a q hat of 1/2. We need an error, and our error is how close we want to be. So we're within 3%. That's got to be a decimal, 0.03. And then the last thing we need is a ZC score. And for 95%, again, we're going to use inverse norm of 1 minus 0.95 over 2, which is inverse norm 0.025. And that's our 1.96. So we're going to plug that into our formula. So n is equal to p hat q hat times ZC over E squared. And that gets us 0.5 times 0.5 parentheses 1.96 divided by 0.03 quantity squared. And we'll practice typing that in the calculator. So this is 0.5 times 0.5 parentheses 1.96 divided by 0.03, close parenthesis, square that. And again, because it's people, we're going to always round up. And this is 1068. What if we're given the same conditions, but we know a preliminary estimate gives a p hat of 0.31. We're given a preliminary p hat of 0.31. That's going to change our calculations a little bit. So if we know p hat is 0.31, then we know q hat has to be 1 minus 0.31, which is 0.69. Therefore, now we can plug that into our formula. Our p hat's no longer 1/2. It's now 0.31 times 0.69, parenthesis 1.96 over 0.03. All of the other information stayed the same. So now we have a 0.31 times 0.69, parenthesis 1.96 divided by 0.03 squared. And again, because it's people, we're going to round up. So we're going to call that 914. Okay. Go ahead and pause the video and try yourself 4 on your own. Okay, so before we start, let's establish some information. For part 1, for part 1, no preliminary estimates. So we're going to use a p hat of 0.5, a q hat of 0.5. We're using a 90% confidence interval. So that's a ZC score of 1.645 using our inverse norm. And we need our error. We're within 2%. So E is 0.02. Therefore, N is 0.5 times 0.5 times quantity, 1.645 divided by 0.02 squared. We're going to type that into our calculator and round up, 1692. And then option 2, what if we do know a point estimate? So P hat is 0.31. That means Q hat is 0.69. N is 0.31 times 0.69. Everything else stays the same, 1.645 over 0.02 squared. We're going to punch that into our calculator, and that is 1448. Okay. That takes us through population proportion for a confidence interval. Homework for section 6.3 is 1 through 20, 12 through 24 evens. Have a good day, Maroons.